Hello everybody and welcome to the 2021 HAS Global Webinar. I am Anna and first of all I would like to thank the people of HAS Bio that organized this 3-day journey and brought us all together. I am beyond thankful and honored to be among all those people. So to begin with, in my presentation I am going to show you a few things about how I create with Amber using digital and analog workflow combined or separately. So controlled crystallization can create a category of materials with promising properties for many uses. Those materials are called glass ceramics and they are composed from a mixture of glass and a regulated percentage of crystals. Lithium disilicate is one of the glass ceramics. Lithium disilicate is the most modern form of pressable ceramics. Its main crystalline phase of the core is lithium silicate. You can find it available in the form of cylinders, also known as ingots. Many companies produce and sell lithium disilicate nowadays, so there are a lot of different kinds of ingots that vary in color and translucency. For example, there is HO, high opacity. It's a less translucent material, perfect for covering up discolorations or metallic posts. MO, medium opacity. Also very little translucency, gives very good coverage and vibrancy to the restoration. LT, low translucency, is like pure dentine. It has high fluorescence. It is ideal for the use with the cut-back technique on crowns and veneers. HD, high translucency, mainly used for staining techniques on monolithic restorations. A tip when using HD is selecting one shade lighter than the actual final color so that you do not lose any of the color or value while staining or glazing. And then there is MT with coverage in between of LT and HD and many more depending on the company. For the use in digital technology, the CAD/CAM systems, we can find the ceramic material in the form of a block or a disc of lithium metasilicate, which after finalizing the digital process, meaning scanning, designing and milling the case, the restoration undergoes crystallization through heat treatment, and the crystalline structure changes to lithium disilicate. Basically, lithium disilicate can be used as a core material for all the different kinds of layering techniques, for monolithic restorations, or as a veneering material. The indications are inlays, onlays and overlays, veneers, anterior or posterior single crowns, and 3-unit bridges up to the second premolar. I must not forget to mention that lithium disilicate can be used as a veneering material over zirconia frameworks and also for manufacturing custom abutments and hybrid crowns. Now let's see a case where digital and analog workflow was used simultaneously, but also separately to manufacture 2 monolithic crowns. I begin with a scanning of the model, the antagonists and the occlusion, and then I proceed to the digital design of the restoration according to the morphology and the occlusion. After that, I decided to follow this particular case in 2 ways, and by that I mean we milled 2 different materials. We cut those full anatomy crowns on a wax disc, which we left on the side for a while, and we got amber mill. lithium disilicate blocks, so let's start with that. I got here a video of the nesting and the milling. First, we do the nesting. Of course, nesting is the process of positioning the restoration on the block digitally with the most favorable way. Then we attach the sprue, the small holding bar, and the milling procedure begins. Always with water spraying. Also, it's a gradual procedure. First, the external part of the block is removed, and the outer part of the block is cut. That leaves us with the general shape of the crown that we designed, and then it continues giving a more specific morphology, the inner part of the crown. I will put it on the die. And now it's about to start creating the occlusal part of the crown. And when it's done, it lights up to let us know. So it's finished. And here is what we got before and after the milling. A closer look before we cut off the sprue, the holding bar. After I cut off the bar, I start checking the fit of the restoration on 3 points, and those are the fit on the die, the fit on a solid model, and the occlusion. Then I attribute any other characteristics or morphology and micromorphology, and of course I do all of those things before the final crystallization because the material is softer and so it is easier to be grinded. Then I move on to the heat treatment. It is necessary that we use a firing support paste, stabilize the crowns on the pin, and here are the crowns after the heat treatment. Mainly, what contributes to this result is the temperature depending on the holding time. Here is a demonstrative chart, for example, for the furnace that I personally use, and mainly I prefer the standard mode. So this chart shows how how temperature affects translucency, meaning that from only one block of amber meal, you can get 4 different translucency levels by changing the temperature here. Meanwhile, we get back to the milled crowns. Check the fitting here too. and remove approximately 1 millimeter of wax around the cervical area, which will be later filled with special cervical wax so that the fit is really precise. We attach the sprues and prepare for investing. So here we follow the lost wax technique. Here is the result after pressing and removing some of the investment material. Sandblasting, cutting the sprues, and finally this would be the result for any of those two techniques we followed. Either it was a milling or pressing. And after sandblasting and cleaning the restoration from any kind of impurities, we go on to the staining and glazing. I use those very fluorescent materials that differentiate from the usual staining and glazing pastes because of their consistency, which includes more fine-grained ceramic elements, and that is why they're categorized as liquid ceramics. So here are the applied stains before the firing. I used a mixture of glaze flora with A+ to reach the desired color. Some cervical too on the cervical area and on some abrasion points. A mixture of glaze flora with white to point out some whitish zones. A bit of reddish brown in the depth of the grooves, some grace blue with clear glaze to emphasize that opalescence effect, and a mixture of white with a little bit of mamelon one on the cusps. Then we stabilize the crown for the firing, and this is the result after the first firing of the stains. After that, I apply a thin layer of clear glaze. Stabilize and fire, and the crowns are ready. Of course, the staining and glazing can be done in one stage, but I believe the result is more lifelike when it's done in two separate steps. Finally, the crowns on the model and in the mouth. This next case is 4 amber press veneers with micro layering. This was the initial condition of the patient. We made a wax up. When the dentist checked the wax up with the patient and everything was fine, we copied the wax up and did a minor cutback on the incisal part. This is the result after pressing and fitting the veneer. After firing the foundation stage, the veneers build up on the model and on the patient. This was a quick and minimal but great change for the patient. So this next case, we have two centrals. The one is a bit dyschromatic. Here we have the initial situation of the patient. From the picture we can see that one of the dies seems to be kind of dyschromatic. So I chose to make two simple copings, two wax patterns. I attach the sprues and prepare for investing to follow the lost wax technique. This is the result after pressing. I chose medium opacity MO0 so that I can cover the dyschromia. Here are the copings fitted on the model. And we begin with the foundation stage. I used two different materials, a very reflective pearly white on the dyschromic one so that it can be blocked even more, and dentine on the other. And here is the result after firing. The difference is visible but very little. And then I proceed with internal staining to the desired color. Here you can see how whitish the core material is in comparison to the desired final color. Then layering, the result after firing, grinding and attributing any characteristics, morphology, micromorphology, pre-polishing by hand, and the restorations glazed on the model. Here you can see which one is a dyschromatic dye. I had painted one of the dyes, the one that was dyschromatic, so that I can check on the model if I had any any color breakthroughs. Here is a palatal view. the core, the inside of the crown. You can see how whitish the MO0 is. And the result of the crowns in the mouth. Even though here in this image the incisals are a bit dehydrated. Here is a palatal view and a side view where I guess the hydration is back and the color matches perfectly. So next on this case we have one crown and 7 veneers. 2 of them, those on the premolars, will be full anatomy veneers. We begin with the digital design of the case. After milling, all the restorations are fitted on the model, and all the modifications that need to be done are done before crystallization, of course, because of the softness of the material and of the more easy way of grinding it. You can see here the thickness of the veneer and the perfect opalescence this material will give us. So we proceed to the heat treatment and we stabilize the restoration separately. The 2 premolars first and the rest of the 6 anterior restorations. The premolars are heat treated to high translucency because they will only be stained and glazed. And the rest are heat treated to low translucency because of the thickness. That's because we did not want to lose any color or value. We move on to the layering of the 6 anterior restorations. And finally the result. Unfortunately this is a very last minute case, so I don't have a picture with the restorations in the mouth of the patient. And so now we have in our hands this new material, Amber Press Master, with the ability to be pressed in 945 degrees in comparison to those 925 degrees of the most pressable ceramics. Amber Master has a higher glass transition temperature, which makes it compatible with more and more veneering materials that have a higher melting point, like IPS Imax Ceram, EX3 Press LF, Cesar Press LF, Creation ZIF, and many more. On a study case that I performed with Amber Press Master, I manufactured and pressed some copings. I did the foundation stage. This is a coping before the foundation firing. The coping after the foundation firing. The result after the firing of after the first firing of the veneering materials. Next, I did some internal stains, some more layering, and giving the restoration the final shape with enamels and lusters. Also finalizing the palatal side of the restoration. And here's the final result after approximately 5 firings with absolutely no problem in the fitting and no cracks. So this was it for me. I want to thank again the organizers of this webinar and also the ambassador program that has helped a lot to connect and share knowledge. I also want to wish good luck and congratulations to all the ambassadors that are presenting during this 3-day journey. If you have any questions, please do not hesitate to contact me. I wish you all a great rest of the summer. Thank you. Bye.